Okay, so as promised today, we're going to drill down into pattern languages and some of their frontiers, I think. We've talked about how throughout the course, we're learning more about the structure of nature and some of our scientific models that are becoming more advanced in understanding how networks function, how networks transform, and how we can use them more effectively. And that's really what the pattern language methodology is all about. So can you see that okay?
Yes. No, it's okay.
Perfect. All right.
Everything is fine.
What we're going to do is talk about the structure of design in a way that is better suited to the nature of our problems, what Jane Jacobs referred to as a web way of thinking. And if we want to put that into practice, then we're going to need tools. We're going to need methodologies that will allow us to do that. And that's really what patterns and pattern languages are all about. You know, we've learned a lot in the last several decades, certainly since Jacobs was writing about network science, about graph theory. Dominic, I think you probably covered that in your mathematics, or you teach that, I suspect, in your mathematics work. And the idea that we can understand how different patterns of connectivity allow you to do different things, like the famous problem of going across the bridge in Königsberg. You know, there are 7 bridges and so on. There are things that you can do with certain patterns of connection that you can't do with others. And you can do very remarkable things when you're talking about the dynamics of a city and the dynamics of how people interact and how they're creative and how they exchange with one another. And so this is really an important subject, understanding how systems of connections function and transform over time. And that can be, in the case of social networks, there's a lot we're learning about that. Economic networks, a whole lot we're learning there. Technological networks, ecological networks, and of course, urban networks, especially when we're looking at the networks built upon urban space and public space. And the fundamental issue here is the issue of connectivity, how these different parts of a structure are interconnected with one another. If they're interconnected in a tree-like way, at this more fragmented pattern, then obviously there are certain things you cannot do. You can't connect across those little nodes without going all the way back down to the tree trunk. And in the case of a street pattern, for example, that's a big problem. It means that it's not a very walkable street pattern, whereas a more interconnected pattern, a more grid-like or web-like pattern is going to be much more conducive to walking and to biking and other modes of transport. And in many other domains, the same kind of connectivity is helpful if you're talking about the interconnections of space on a city street or within a building or in any other urban domain, really. And this includes not only spatial regions, but other kinds of interconnections of different kinds of actors, as Bruno Latour referred to it in his work on actor network theory. The actor can be not only regions of space, it can be people, it can be institutions, it can be buildings, it can be really anything in the urban system or anything in a social system. And what we want to understand is how they are interconnected and how they are in some ways not connected, because that tells us a lot about the relationships and the overlaps that are possible. Remember how important it is to have those overlapping relationships inside of that sort of web network. This is an example, an illustration, by the way, from Aging in Place and the Internet of Things, where we're thinking about how people who are living in their homes can be assisted by technology. So we have the interconnections of people, connections of technology, connections of their homes, connections of the institutions that are monitoring them, all those things that we're looking at. And we're managing those things. We have to manage those things if we're going to successfully allow the technology to support aging in place. So that's an example of that. I've also written about and I've talked a little bit before about how the structure of the brain also in some ways mirrors the structure of a city. This is something that a number of people have written about before. Stephen Johnson has a book called Emergence, the connected lives of ants, brains, cities, and software. So he makes the connection between brains and cities as well, and a number of other things. And he talks about Jane Jacobs and you know, a lot of these same issues that we've been talking about. What's useful about that is to recognize that in the case of brains, we are forming new relationships. We are learning, right? We are adapting to changing conditions and self-organizing. Our brain cells are self-organizing. There's nothing outside of our brain cells that commanding them about how to behave. Maybe we're studying a particular, you know, piece of material for a test or something, but it's our brains that are doing all the work, and they are self-organizing in that process. And the same thing is true to a large extent with cities, that we are adapting and learning, so to speak. The cities are learning, they're forming new relationships that are accommodating the changing conditions, and whether that's you know, disruptions, storm events, catastrophes of various kinds. That's where resilience comes in. So these are all very important capacities that we need to understand and recognize in our cities. And understanding this kind of structure will help us to formulate better urban policies and practices. I'm convinced of that. And I made that case in this piece that I wrote about it. And so this is also the case with, you've heard the term third places. This is a work by Ray Oldenburg and others. The idea that it's not only our homes and it's not only our workplaces, but these third places that are maybe in public space, or maybe they're adjoining public space, the cafe, the pub, and so on, where we are interacting with others and forming social relationships. They can be third objects as well, like if we're in public space and there's the third object might be a dog, or you know, a pet, and you're able to interact more freely with that third object than you would be with the person directly, because that would be socially awkward. You wouldn't just walk up to a stranger and say, hello, how do you do? My name is so-and-so. It almost never would you do that. It might seem socially inappropriate, and it might be somewhat intimidating. But if the dog runs up to you and starts, you know, licking your hand and whatever, and then the owner smiles and you smile and you say, oh, is this a, you know, German Shepherd or, you know, Basset Hound or whatever, then you now have a connection to that person that you wouldn't have had otherwise, because of that third object, that actor network system that has just been formed between you and the person and the dog. And this is what goes on all the time in cities and needs to go on. You remember Christopher Alexander talked about this. The third object in this case was the newspaper rack. And there was a system of the newspaper rack and the street light, and the person standing on the corner waiting to cross. And the street light, if it was red, they would be more likely to look at the newspaper rack, and so on. And it's an interactive system. There is no sort of commanding agent within this system. It's a kind of rock, paper, scissors relationship that's very important. And so I think really since the early 1960s, we've begun to tease out this essential relationship between the elements of a design problem, the elements of a configuration that we're interested in. We're interested in designing it. You know, we're interested in transforming existing conditions into preferred ones, as Herbert Simon put it when he defined what design actually is. And he noted in this important paper, The Architecture of Complexity, that design problems tend to be nearly decomposable hierarchies. They're nearly decomposable because they're not quite perfectly decomposable. And that's something that is noteworthy, was noteworthy in his work, and was really the landmark finding for Christopher Alexander, taking that forward into his idea expressed in The City Is Not a Tree, the idea that overlap is an essential ingredient in the structure of something like a city or a neighborhood or a newspaper rack, or any of these components, the actors in the network that are such critical components. And furthermore, that you can begin to tease out different kinds of relationships between these different areas, the different nodes. Some of them have weak ties, They're not particularly strongly related. You remember we were talking about the other day where the different doors in a room don't have to be in an exact relationship to one another. They can slide around. And some of them have strong ties. The hinges and the knob on a door have to have a certain kind of configuration or else the door won't work. And this is the way our environments are constructed and the way that our social networks are constructed too. We seem to have weak ties and strong ties. And both of those are very, very important, it turns out. But what's neat about this finding is that we can now begin to extrapolate the clusters that have strong ties and work on them within a system of weak ties. And that is the essential concept of a pattern language. That's the idea that we can abstract the patterns, these clusters of strong ties, and we can now manipulate them within a weak tie network, within a pattern language network. We can talk about how a room might have a door on one side and a door on the other side and so on. And that in turn might become another pattern, another strong tie at a different scale. You remember, Dominic, going back to Aristotle's hylomorphism, there's a strong relationship there that the matter at one scale becomes the form at the next scale and so on. And so this is the idea, the essential idea behind Alexander's landmark 1977 book, A Pattern Language, where he and his colleagues, a group of students actually, distilled out 253 of the, 253 of these patterns at all scales ranging from the scale of a door, for example. A door isn't actually a pattern in the book, but it's down to that scale, all the way up to the scale of cities and regions and even nations, starting at the beginning of the book. And this is an example of paths and goals, very similar to Lynch's idea that you have paths and nodes, so to speak, and how the goals actually function. So this is the idea of a pattern, as I was describing the other day. It fits into a network of structured options. It's a nearly decomposable hierarchy. The hierarchy is the scale. And so it's not entirely all at one scale or all at one level. There is a nearly decomposable hierarchy to pattern language. And as I said, pattern languages have become widely used tools, especially in software. There is just an explosion of use of patterns, design patterns as they're referred to. They've been used in many examples of software. SimCity, Will Wright talked about how influenced he was by pattern languages. Wiki, Ward Cunningham documented that he created the wiki, the first wiki to exchange design patterns or pattern languages of software. And that really each wiki is a kind of pattern within a pattern language. And that was the logic of Wikipedia. Ward was a consultant to them and has been an advisor on the board and then had other relationships with them, helping them to get Wikipedia structured, because that is very much the essential structure of Wikipedia. It is a kind of language of patterns, if you will. Each pattern has if you think about a Wikipedia page, there's the title, there's an iconic photo, usually there's a description of what the thing is or what the problem is in effect, and then teasing it out, and then there's hyperlinks and so on. And so this is the ubiquitous structure of patterns that you see in many, many examples in software and programming and Agile methodology. It led directly to Agile, Scrum, extreme programming, if you've heard of that methodology as well. All of them are trying to simplify the design process and eliminate the sort of overcomplicatedness of specifying everything and trying to get to the core generative components, the core generative networks that are going to produce the structures that are well adapted to what we actually need for the design problem, whatever it is. And there are examples in architecture. I myself have used pattern languages in many projects, in fact, and this is an example of a project pattern language where you take particular architectural problems. In this case, they're problems that allow generativity. And so one of the problems that we have in the design world is how do you do attached buildings and not do them as one master designer designing the whole row of houses, row houses at once. How do you allow different designers to come along one after another after another? It turns out that that's quite a complex problem because there are all kinds of issues about how do you make the party wall, how do you make the eaves when they overhang each other. There are fire issues, fire code issues. There are many different kinds of problems that you come across. And so this pattern deals with those problems in a fairly simple form. It gives a simple set of rules for how you would do that, how you would iterate the next building and the next building and the next building, and allow when you're leaving the side open for the next building, how you would do that, how you would build the side to the previous building and so on. That's an example of an iterative algorithm, if you will, that the pattern gives you the information about how you can actually do that. Here's another example where if you're trying to do single family detached homes and you're trying to activate the side yard, you're trying to create outdoor space that's usable, that doesn't just have a property line and a fence running down, chopping it into two unusable fragments. Well, there's a way that you can actually do a reciprocal easement and get half of the yard of one property to be used for the benefit of the other property, and the same thing on the other side of the next house, and the same thing on the other side of the next house, and so on. So that is a kind of generative process as well. If you were selling those houses one after another and creating those easements to allow you to do that, to activate those side yards, that's a mechanism that is encoded into the pattern. Here's an example where if you're trying to do a more deflected street, you don't want to just create a ramrod straight street, but you want to, and you also don't want to simply compose a street that looks like it was created by many different people evolving over time. You want to actually allow that evolution over time and that dynamic deflection and adaptation and so on, that is the characteristic of many of the beautiful cities that we know and love. We talked about Venice and other examples. So here's an example that fits within the legal system today, where you have to create a tract of land, you have to create an easement, a right of way between the tracts of land. And then what you do is create, in effect, what we call dummy lots. These are the lots that are platted, and then you allow those to be adjusted and deflected and changed over time. There are mechanisms that allow you to do that, lot line adjustments and so on. And so this is a methodology that allows the system that exists today to, in effect, recapitulate the behavior of these dynamical processes that occurred in the past. Again, we're trying to, in effect, use a self-conscious process to recapitulate the unself-conscious process that existed before, using a modern system, using a contemporary system, using the operating system for growth that we are now saddled with. We have to make it work somehow. And this pattern gives you the methodology for doing that. So I'm using pattern languages in many different projects very successfully. This one is 7,700 acres, about, what would that be, 3,000 hectares or something like that. Other smaller projects, urban extensions, brownfield developments. There's the Fresno project is actually a former Christopher Alexander project where the owner is interested in redeveloping it and around the Christopher Alexander work and adding to that. There's an airport redevelopment, many different kinds of projects. So what I find it really rewarding and also I think very instructive is that I can have this kind of practice. I can do design, I can do urban design, I can do building design, I can, get involved at many different scales. And I know we were talking about that yesterday and what the opportunities might be for actually doing design and still embracing these new methodologies and new ways of thinking. And I think there are ways forward there that I find really positive. And the users are very happy quite often with these methodologies. This is the one in the Vista Field project in Kennewick, Washington, that they use the methodology talking about the unique qualities and values, the sense of place, before the types of use, that sort of all the stakeholders get together and understand the vision of what they're trying to create. And as Carlotta Collette, a Metro Council member in Portland, talked about architecture that can be timeless, that feels like it really grew there. The Planning Commission in Milwaukee, which is also part of the Portland region, looking at things we like and saying, let's keep this, let's build on this, let's use pattern languages to document that. So I mentioned Ward Cunningham's work with Wiki, and his new generation of Wiki is something that he calls federated Wiki. And I want to talk about that a little bit because, again, it's a direct extension of the logic of patterns and pattern languages, as he and I have written about. And the idea of federated Wiki is that it, first of all, it exists on your browser. You can use it right on the computer or on your smartphone. And it works with data. It isn't just text-based patterns. You can actually calculate things and do interesting things. So what Ward did when he was understanding this and developing this is he imported the original pattern language into the new wiki. And he's displaying it here as if it was a series of cards, but it actually is either shows on your handheld smartphone or else shows in a series of tiles on your computer, which I'll show you in a minute. So there's some of the original patterns from a pattern language that are taken into this format, as you can see. And here's an example of an economic pattern language that was developed by EcoTrust in the Portland region. My friend Stuart Cowan played a key role in developing this pattern, looking at some of the economic patterns of how you would describe those, how you would interrelate those. You can see the hyperlinks in blue. Very important work, I think, to take it into the domain of economics. There are many other examples of pattern languages in economics, by the way, and in many other fields, as we talked about. And then here is another thing that Ward did. He went to work for Nike as their open data fellow, and he took their sustainability in material sustainability index that they had already developed in a kind of complicated spreadsheet format, and he developed it into this federated wiki system. So, for example, a Nike shoe designer can say, well, I'd like to use a cotton fabric, maybe I'll try a polyester fabric. Let's see, okay. So I'll put these different fabrics together, I'll see what the material summary is. That will produce the calculations will be made between these different patterns. That will produce a radar chart, a material scatter chart, these analytical tools that show me how my shoe is performing in terms of the sustainability index and the goals that I'm trying to achieve. You remember when we were talking about the Sustainable Development Goals. So here is a pattern language methodology that essentially allows you to do scenario modeling. I'm going to make a shoe and maybe I'm going to use cotton. No, maybe I'm going to use polyester. And you can try out these different scenarios by moving the patterns around, by essentially building your scenario with these individual patterns into a pattern language. And this is what it looks like on the spreadsheet, where you can see the calculations being fed into the radar chart, going in sequence, making the calculations between the different pages or the different patterns. So that's the data that's flowing, that's being calculated in a scenario modeling process that allows you to vary the scenarios and see what the results might be. And so he and I worked on a number of different models. This is one where it actually led to my dissertation work later on, as I'll show you. But it was essentially the idea of, okay, let's see, what if you did something more like a Renko station instead of the usual sprawl? What if you had a town center? What if you had live works? What if you had mixed use buildings? And could you develop predictive algorithms for each one of those for how much it would reduce whatever the metric is that you're interested in, reduce trips, for example. And there's methodologies for what's known as trip capture when you have a mix of uses, for example. And so you can get that data and you can try it out and you can see how the model performs. And by the way, if the model is not performing well, you can improve it. You can actually develop new algorithms or new predictive formulas. And that's essentially what is known as Bayesian methodology, where you're starting with something that's not particularly accurate as a prediction, as a statistical prediction, and you're making it more and more and more and more accurate over time. In exactly the same way, by the way, that Wikipedia started out quite dumb and almost comically inaccurate, and is now remarkably reliable at least as a background research tool, not a formal research tool, but certainly reliable to understand as a citizen or even as a researcher, what are some sort of broad linkages in a topic and how those work. By the way, a lot of sophisticated AI programs now use Wikipedia as one of their data scraping sources in order to build up very, very accurate and shockingly accurate AI outputs for things like text generation and other sophisticated chores. So this is powerful stuff. This is powerful technology, and I think it's really the frontier in many ways. So this is what Ward and I were doing back then. Then we developed a lot of other examples, other tests, and we had the idea, what if you could have a repository where all of these things could sit together in a kind of ontology or a kind of library of different kinds of patterns that you could then pull from this repository and put them into your own constructions and say, well, I'd like to have a town center, and I'd like to have bioregional economies, and I'd like to have positive outdoor space, whatever it might be. And of course, you have to figure out whether these patterns are going to be compatible, and maybe you're going to have to do a little bit of work to make sure that the data transfer is in the right format and all that sort of thing. So I think there's a huge opportunity for pattern languages, for project pattern languages, for particular tasks, where we can take that methodology and apply it to many different challenges, many different projects at many different scales, modeling projects, design projects, and so on. A couple of other examples. I think I mentioned this the other day with Ward. Ward and I met with a official in the city of Portland, Greg Reisman, who's the bicycle transportation coordinator. And we looked at some of the examples that they have developed in Portland, quite innovative little configurations of bicycle lanes. And of course, many other cities are doing that too, Amsterdam and Copenhagen and many others. Could you compile those into a shareable pattern language? Bike greenway, median cuts, intersection arts, et cetera, et cetera. There must be thousands of these that you could put into a bicycle pattern language. And then you could even potentially do some metric calculations of whatever you wanted to add to those. You can build on the patterns and you can do more things with them. We talked about biophilia in the previous lectures, and the idea that a view from a window can actually be quite salubrious. We're next to a beautiful park right here, and it's quite wonderful, in fact. So here are some of the biophilic pattern languages. The healing garden that can go right into the hospital and is shown to improve wellness. Single bed rooms, I talked about, that cuts down on the transmission of pathogens like the MERS virus that's such a problem in hospitals. View to nature, as we were just talking about, how important that is, and so on. So you could certainly do a lot more of these kinds of patterns and build them into this kind of language. Here's a neighborhood wiki pattern language. This grew out of our work in New Orleans after Hurricane Katrina. And in fact, that was when I met Ward and Christopher Alexander and I and Andres Duani and a number of other people got together and said, look, one of the fundamental problems that we have in New Orleans is that people don't have access to the resources right on the ground where they need to rebuild their homes and their businesses and their neighborhoods. And what you need is centers in the neighborhood that will allow that. And those centers need to have open access data platforms like a community design wiki that allows people to see what's going on and contribute to it and say, hey, I need this, or hey, I'm coming back, or hey, I'm looking for a contractor, do you know one, et cetera, et cetera. And also streamlining the regulatory complexity, which was absolutely nightmarish after Katrina, and is nightmarish even in a normal situation. But when you have people who have to go to the insurance company or the plans examiner, and they say, let me see your existing plans, let me see your deed to your house. Well, all this washed away, you know, I don't have any of this anymore. And so we needed and still need a streamlined process where you have things like pre-approved plans and pre-approved plan elements, plan patterns maybe, or remember the pattern book idea that allows people to very quickly get good quality designs. We were partnering with the neighborhood, with the Preservation Resource Center in New Orleans about how you would design, how you would restore a historic building very accurately and very beautifully, but not without a lot of cost and without a lot of complexity and difficulty, because of course you need to get into your home as soon as possible, and you don't want to create a kind of Frankenstein monster that is not accurate and isn't a good design. So you would have many of these kinds of elements in this neighborhood center. To make a long story short, we ran up against another kind of regulatory problem. We proposed this to the authority there, the Louisiana Recovery Authority, and the executive director was very excited about this, wanted to fund a pilot project. We were working with the Neighborhoods Partnership Network there in New Orleans and many other partners. We had, I think, 10 or 12 partners involved in this. And then they took it to the attorneys at the state, and the attorney said, no, we can't do that because open data means somebody could sue the state if they disclose some proprietary information. Looking back on that, that seems ludicrous now if you think about how that happens every day on Facebook or on, you know, any of 1,000 other websites. And of course, there are disclaimers, and this is a well-established area of the law where this isn't a problem. But at any rate, these are the kinds of barriers that you come up against when you're trying to implement reform, you know, when you're trying to change the operating system for growth. Another important subject is how you quantify the qualitative, how you understand people's qualitative evaluations of, say, a neighborhood or a city or parts of a city. And our colleague and friend Yodan Rofé done some work on how this mapping can work. He calls it a feeling map. And his methodology originally, he did his dissertation on this, was to essentially do it manually, to go out, have people go out as a group and do feeling maps where they would essentially evaluate the qualitative characteristics of a place. But now we can do that with a handheld smartphone, and we can do it with GIS, and we can do it with all kinds of other sophisticated methodologies. People are doing things now like looking at Facebook likes and at photo uploads and things like that to get very sophisticated, actually, GIS data about how people are evaluating different urban areas, how popular they are, what people are feeling. They can even go in and look at the words that people are using, happy, sad, terrible, ugly, etc. Although that's all controversial because clearly you have to be careful about what the context is when people are, using messages like that. And of course, you've got to be careful about the data privacy aspects of all this as well. And so my work, when I began my dissertation some years ago, was to say, okay, can you take the similar methodology and do greenhouse gas emissions modeling? Can you look at, for example, the impact of the impact of urban form on greenhouse gas emissions per capita? Because I had been doing some research on that topic. I was played a key role in a conference that we had on that topic, and then went to the COP15 conference in Copenhagen back in 2009, I believe it was. I was convinced that this was a very important goal, not only because greenhouse gas emissions are an important issue and climate change is an extremely important issue that we need to deal with as a critical challenge, but also it's the ultimate systems problem. If we can deal with something as pervasive as greenhouse gas emissions, which after all is a global phenomenon, we can deal with a lot of other things too, like the economic performance or the other kinds of metrics that we might be interested in for sustainability. So not to get too far into the weeds here, but we began, Ward was an enormous help to me to begin to construct a modeling, scenario modeling tool to model these externalities, in this case, the externality of greenhouse gas emissions. But you could model any kind of externality in principle following a similar methodology. So here's examples of how you take, say, residential neighborhoods, whether you have single family versus attached, whether you have a more compact neighborhood and so on, and you apply the algorithms based upon the research, what the research tends to show for that from the baseline to the delta that you would get by going to the alternative scenario. And you can do that for many different things. We tried out some other experiments on things like the municipality's return on investment for infill versus out of town development and understanding that as a return on investment. This is work that Joe Minicozzi and Chuck Marone and others have done. And we simply took that methodology and said, could you apply something like that to a wiki tool that would give you that information so that you could go to the municipality and say, hey, you know, this big box that you just approved out of town, they dangled $1 million check in front of you and you thought you were doing great, but actually your return on investment is pretty crummy when you look at all the services you're going to have to provide, the infrastructure costs, the fire and police and everything else. Look at what you're doing when you do infill. Even though each project is smaller, in aggregate, you're getting a far, far better return on investment. So this is a tool that could begin to show that and begin to convince people that, you know, there's another path that they could take. And so when you think about the new urban agenda, I think we have to recognize that although it's a great milestone, there's no question about it. 193 countries have agreed on a framework for urbanization for the next 20 years. But how are we going to implement it? One of the things that it calls on is at the end of the document is peer-to-peer learning with open, user-friendly, and participatory data platforms. Well, that certainly sounds like it was designed for Wiki and for Wiki-like tools. And so that's what we said is, hey, let's see how far we can go with Wiki. So this was the inception of this project that I'm going to talk about next. And I mentioned it in the lecture the other day, and I have the book here. Anna, you can peruse this if you want to. It's called A New Pattern Language for Growing Regions, Places, Networks, Processes. One of the things that we wanted to explore was, first of all, what the book itself says in the beginning, the original book, which is that this original book is only the beginning of what we consider will be many more processes, many more examples of this kind of project. And we also constructed an online version, a wiki tool in Federated Wiki that was a companion to that, and I'll explore both of those. We launched both of those at the World Urban Forum in Abu Dhabi in 2020. Seems like a lifetime ago, right before the pandemic. And now next week, we're going to Katowice for the next World Urban Forum. And we'll be talking a lot about implementation there, I'm sure. So this was a partnership with UN Habitat. A number of their colleagues participated in helping us with this volume. And then we also work closely with a number of other collaborators, people who had been students of Christopher Alexander or colleagues of his in various capacity, other colleagues of ours who had been using something like a pattern language methodology in their work. And here's what the wiki looks like. You can go to this, by the way, you just go to type in npl.wiki, npl.wiki, and it will come up. The actual the URL that's in the browser here is actually an older one that we don't use anymore. So there's a welcome page, and then there's a page that tells you sort of overview, and then you can jump down into the different categories and surf the network in essence between the patterns, and you can see the hyperlinks and the sort of nearly decomposable hierarchies, the overlaps, right, between the different patterns, because those are what are contained in the hyperlinks between the patterns. Again, the beauty of the pattern language methodology is that the hyperlinks create these web-like overlaps and you know, nearly decomposable hierarchies and so on. Here's what some of the different pattern groupings look like in the pattern. You can see again the relationship between all those different patterns and the categories and the relationship between the categories and so on. And then here's the table of contents. And you'll see that a lot of these patterns look similar to the patterns in the original book, although they have a much greater focus on a global audience, particularly the audience of rapid urbanization. That's the context of the new pattern language for growing regions. There's much more attention paid to the global South. You know, in the original pattern language, there's a pattern called South facing outdoors, which, you know, for half of the planet, that's not the right pattern. It's like north facing outdoors, if you're in the Southern hemisphere, would be the right pattern there. So many of these are, you know, supplements that we think are very much needed to have a more complete and more, you know, globally useful compendium of patterns. And we only have 80 here. The goal was to create a series of groups of 4, each of which is a sort of proof of concept for that particular category. And so you have regional patterns, urban patterns, street patterns, neighborhood patterns, again, going down the scale as you're breaking it down and looking at how the neighborhoods or the structure, the urban structure might be optimized according to these kinds of patterns. A lot of this is based upon, you know, I mean, really all of it is based upon research and work that's been done previously and work that we have been talking about all along, the work of people like Kevin Lynch and Jane Jacobs and many others who have been talking about these issues. Many of these are also very similar to the work you see in the New Urbanism and the work in the New Urban Agenda. Again, a lot of the issues about public space, about how the buildings are the edges of public space and they're creating the adjacencies, creating the ground floor uses and so on. And all of those kinds of patterns, building edge patterns, how those work, how the geometric relationships go. And that's something that I want to emphasize, the idea that we're now going into the domain of geometric patterns. You remember that Alexander, when he finished the pattern language project, he was very disappointed that people were not able to do good geometric configurations as a result of that. And that was really the genesis of his work on the nature of order, which I'm going to talk about more in the next lecture. But essentially, what he was saying is we've got to deal with the problem of geometry. We've got to deal with the problem of form and how that actually needs to work. And so at one point, he and I were discussing this. You know, he was my former professor and colleague. We worked together. He was a dear friend. And one thing I asked him at one point was, did you ever think, Chris, about using the pattern language methodology to get into geometry and actually have patterns of geometry? He said, yes, I did, but I chickened out. I think, well, maybe it would be a fairer statement to say he felt that he wasn't ready. He felt that he had to deal with the theoretical aspects of it first, which is what he did with the nature of order. And he left it for other people, as he's left so many things for other people to take forward, to explore that potential. He never said you can't do it. He just said that I didn't do it and I was moving on and looking at other things. So we said to ourselves, well, let's explore that. Let's see if we can take patterns of geometric form and begin to describe those. You know, we were talking about local symmetries and fractal patterns and so on, framing, which is the same thing as boundaries, you know, some of the properties that he described in his later work. In a sense, the nature of order is more of a theoretical backdrop for what would be the operating system, in the same way that the other book that he wrote about the same time as the pattern language, called The Timeless Way of Building, was the theory, and the pattern language was the operational system. So what we wanted to explore was, could you take the theory of the nature of order and use pattern language methodology as an operating system, as a way to apply to some of these new challenges, the challenges of rapid urbanization, the challenges of the global South, and so on. And you'll see many other kinds of patterns that are related to geometries, affordance patterns, for example, patterns that create capacity for people to do things like get a handle literally on their environment, to be able to produce things with others collaboratively, to be able to change their environment, have malleability in their environment, and so on. Retrofit patterns going into places like slums, upgrading slums, retrofitting sprawl, regenerating urban areas, and so on. Growth patterns of various kinds, how to, for example, when you're dealing with slums and informal settlements, how to give people land tenure so that they can actually make improvements that are under their control and not confiscated or bulldozed or, taken over by somebody else. Dealing with utilities, which is often the most important part of an informal settlement, giving them the power of data. It's quite remarkable how many slums and informal settlements are now being improved through the ability to have cell phones and the ability to have information about the location of their homes and the addressing and so on. Incremental self-building obviously going on in those places as well. Construction patterns obviously are taking many of those ideas forward. Implementation patterns, we talked about coding and form-based codes, entitlement streamlining, and the sort of Quimby approach, quality in my backyard, getting people to agree ahead of time on what they will approve and how it can be streamlined so that the cost can be reduced and the quality can be improved. Neighborhood planning center, I talked about earlier, community mock-up, so you can have visualization tools that will allow people to see how a given change is going to actually impact their environment and how it's going to look and so on. Economics, I think, is a very important subject to deal with. Various tax and to finance tools, tax increment financing. We talked about that briefly the other day, the idea that if you're going to create a project that creates a positive benefit, a positive externality to the community, and that in turn is going to generate tax revenue to the government, then you can use some of that tax revenue, an increment of that, in order to finance that project, to finance perhaps the public infrastructure part of it. A very important idea. Land value capture, a similar idea. Externality valuation. How can you value those externalities? For example, the greenhouse gas impacts, and perhaps make it easier for people to build projects that reduce greenhouse gas emissions, as we saw in California when we were talking about that the other day. Economies of place and differentiation. I talked about that the other day, the fact that we really need to have better tools to complement the economies of scale and standardization. We do that very well, but we need economies of place and differentiation, and we need the tools and the methodologies to do that. So that pattern cracks that surface of that problem, doesn't go particularly far with it, but cracks the surface of it. Again, these are proof of concept patterns. There's much more that can be done in all of these categories. Place governance patterns. We talked about the polycentric governance and how important that is. Elinor Ostrom was famous for developing that idea, that it's not just about the government, it's also about all the levels of governance, the institutions, the businesses, the people that are there in the neighborhood and in the city. And subsidiarity, the idea that if a democracy is going to function properly, then you need to have a good allocation of responsibilities down to the neighborhood scale and even the block scale and the home scale, and allow people to deal with the problems that they have and more or less autonomously to the extent that they are able to, and that it's appropriate citywide. Rely more upon self-organization than upon top-down command and control. That's not so much a libertarian idea in the sort of radical sense of just let her rip, get rid of government and let everything go. It's more of a smart government and smart governance approach that allows us to, again, take a lean approach, a lean or agile methodology, allowing governance to become simpler and more effective. And I think that would go a long way towards dealing with a lot of the conflicts and the polarizations that we have today in many countries around the world. Public-private place management, this is a very thorny issue. Often the private interests run roughshod over the public, or sometimes it happens the other way. We need a more optimum way of collaborating and maintaining the rights of the public to, for example, use public space that private entities are creating, and so on. Various forms of informal stewardship that are so important as well. Affordability, we've talked about that, how important that is, and how we're losing affordability in so many cities around the world today. And we've got to deal with that, not only with policy changes and recognizing the dynamics of real estate, but maybe doing things like having a more integrated approach to affordability, how to certainly integrate it into the construction costs and the regulatory costs and all of those things, but also to perhaps use taxing tools to deal with the problem of land value and so on, and perhaps a speculation tax that would restrict the use of the financialization of homes. After all, homes are a need, not just a commodity that can be bought or not bought. And the idea of land trusts of various kinds, putting land into a trust so that it can be used for affordable housing. Doing multifamily projects that can accommodate more people, the so-called missing middle, and so on. And then another, I think, important realm is the technologies that we now have. And, Wiki is now on the computer. We now have pattern languages on the computer, but we have many more systems as well. We have autonomous vehicles coming online that are going to be a huge challenge for cities and a huge opportunity too, I think. Transportation network companies are posing a huge challenge. Companies like Uber and Lyft and so on, and the scooters and so on, that are in one way creating a lot of benefits, but also creating a whole lot of headaches, and in some cases, frankly, creating greenwashing. They're not reducing greenhouse gas emissions per mile traveled, not if people are moving from walking or biking onto these other modes of transportation, certainly. So we need to confront these, and we need to manage these, and we need to exploit these as well, exploit their potential benefits. Augmented reality, we're seeing those kinds of tools, virtual reality and so on, coming online. There's some great potential there, certainly for design and for community participation, for community evaluation, visual preference surveys that are much more realistic and so on. And citizen data, giving power to the people to be able to do things like, deal with local governance issues, the potholes and the graffiti and that kind of thing. Smart government, and there are various examples of that have been developed. And then the final section of the book is really looking at some case studies where we point out some examples of these kinds of innovations that are going on in Medellin, where they're informal settlements, they're upgrading those. China is using actually much more sort of new urbanist model than it has in the past. Portland, we talked about a little bit before, and then different kinds of examples of geometries, different kinds of geometries as we've been talking about. So here's a geometric pattern, an example of that. And this is local symmetry. If you remember Alexander's 15 properties, this is one of them, one of the important ones. And this example is actually the Alhambra in Granada. And you can see that within an individual location, an individual part of a building, it's highly symmetrical, but the symmetries are broken and rough and angular, and they're deflected in response to the terrain and so on. So they're local symmetries. There's not a global rigid hierarchical or rigid master symmetry across the whole structure. And that's a very important component as well. We could talk about many other aspects of symmetry, of course, as we talked about. So here's again, the example of the pattern that you've seen, the sort of classic pattern structure where you have the title, the iconic image, the upward hyperlinks, the problem statement, the discussion, and then finally the therefore conclusion, which often includes a little diagram, a little icon that expresses the gist of the idea. And then lastly, the downward hyperlinks connecting that pattern to the other patterns at a smaller scale. And one other very important thing is that there is research, there are always research citations for every one of the patterns. And they're talking about some example, in this case, talking about the nature of order and the property of local symmetry where it's discussed there. And of course, there are other research citations as well in Alexander that you could follow through. So it's interconnecting with all of the sort of network of knowledge that's out there already about these particular issues. And that could be improved over time. Here's another fractal patterns. We talked about that before, and that's similar to Alexander's levels of scale pattern, where you have something that's a big pattern, like the bigger arch, and then the little arch, and then tiny, tiny arches, and they're the same form repeated, the same fragment of a geometry that's repeated at different scales, and that's the idea of a fractal. So the pattern expresses that and documents that and describes how that would work. Actually, I don't have the rest of that pattern, unfortunately. Human scale detail, trying to get down to the scale of saying it's okay. In fact, it's necessary often to have details that are at the very smallest scale, the scale of a human hand, for example, those little motifs that are in that screen there that are very beautiful. And that, in fact, when you're dealing with very, very large buildings like the Hermitage in St. Petersburg there, it's very important to have those small scale structures that we can identify. We can look at those windows, for example, and see and feel the human scale in them, and the whole building is much more relatable to us as a structure. There's a little figure that describes the 1 meter by 2 meter scale that you're wanting to work at in some level of scale, some level of detail. Construction patterns of various kinds and so on. So I encourage you to peruse the book and enjoy the different patterns. Again, they're really starting from the place of the proof of concept for each of these categories. Certainly not exhaustive, but taking it far enough along to demonstrate the issue and to demonstrate also in the wiki that we can put this onto a software platform and make it very navigable and interesting to users to be able to explore and peruse and apply potentially. And I wanted to show one thing. The beginning of the original book, a 1977 book, talks about really outlines exactly this project in very clear terms. In the book, in the original pattern language book, at pages XV to XVII, it's in the introduction. Let us finally explain the status of this language, why we have called it a pattern language, with the emphasis on the word a, and how we imagine this pattern language might be related to the countless thousands of other languages we hope that people will make for themselves in the future. The fact is that we have written this book as a first step in the society-wide process by which people will gradually become conscious of their own pattern languages and work to improve them. And then they go on to say, we hope that many of the people who read and use this language will try to improve these patterns, the original 253, will put their energy to work in this task of finding more true, more profound invariants. And we hope that gradually these more true patterns, which are slowly discovered as time goes on, will enter a common language which all of us can share. Once again, they go on. You see then that the patterns are very much alive and evolving. In fact, if you like, each pattern may be looked upon as a hypothesis, like one of the hypotheses of science. In this sense, each pattern represents our current best guess as to what arrangement of the physical environment will work. And that means, by the way, that we might be able to criticize the patterns. We might falsify the patterns. We might say that certain patterns are not valid or are not sufficient in the way that they're written. I mentioned the south-facing outdoors, for example. I could mention a number of other patterns in the original book that are evidence has accumulated since that they are not accurately drawn and that they need revision. The patterns are still hypotheses, all 253 of them, and are therefore all tentative, all free to evolve under the impact of new experience and observation. This is, I think, a very important passage in the original book, and it's one that we should take very, very seriously. Those, especially those who somehow have swallowed the idea that this is some kind of Bible or fixed text back in 1977 that is unalterable and we shouldn't touch it and we shouldn't tamper with the words of the master or any of that kind of nonsense. That to me is sheer nonsense, because it's, at the end of the day, it's not about Alexander. It's not about that book. It's about all of the logic of all of the things we've been talking about in this course. And one methodology that has emerged that is, I think, very promising and very powerful, that we should be able to exploit. We should be able to take it as far as it goes. And if it's not valid, if it's no longer suitable in the domain of architecture, even though it's been used in all these other domains so brilliantly, then let's figure that out. Let's show that. Let's argue that. And let's produce evidence, for heaven's sake, not all of these sort of crazy cockamamie theories that people have about the images. So the wiki repository, again, very important. You can add patterns to the wiki in that same spirit. You can edit the patterns. You can adapt the patterns to new uses. You can share the patterns with other people in other communities through what's called forking. This is the idea of federated open source technology. And then the patterns can do new things. They can do pretty much what any smartphone can do, or almost what any application can do nowadays. They can do, virtual reality. They can do scanning. They can do GIS measurements, all kinds of things. Numeric calculations, as we talked about, or field measurements. You can actually do surveying various kinds, perhaps not so accurate because of the particular methodology they use, the satellite technology, but it could be rough enough for a community to make approximations. Or again, anything you can do on an app, you can pretty much do, and you can share with different communities through the federated technology and approach. So I would encourage you to explore the wiki, npl.wiki. You can just type that in and try it out. And I would encourage you to peruse the book. I think, did I send you guys the online version of it? I mean, the PDF. I can send that to you if you want to look at that as well. And then, of course, you can also look at the wiki. But the PDF is actually the printed version in a PDF. And the hyperlinks will work in that as well. And then I just wanted to close with this note that, there are still many other frontiers that we could apply the pattern methodology to. For example, what about COVID? What about some of the things that we've been talking about, the lessons of the pandemic about public space and how important it is, and how public space needs to protect us at the same time that it connects us? How about, some of the little parklet ideas that have emerged, like the idea of a dining parklet where you can take parts of the street that are maybe underutilized for parking, and you can create little safe dining spaces where people can dine in groups, and it's open air. They're not transmitting the virus to one another and so on. Or maybe this idea of sociable distancing, as I referred to it before, that you need those kind of connective spaces that are still also protective, like the American front porch or other kinds of frontage zones that allow you to be out in public space and interact with people on the street, and yet be at a safe distance from them, be out in the open and so on. And there are a lot of other examples of spaces that people have created that allow people to be safe in public space. This is one that I alluded to earlier, the idea that it's not just the density. Density got a bad name with COVID, And that is really unfair because it's not only density, it's the pattern of connection. If you're forced into the same elevator or lift, the same central lobby downstairs, the same front doors and so on, then yes, you're going to be in greater proximity and greater risk of transmission of viruses. But if you're distributed in a row house structure, a row house neighborhood at exactly the same density, mind you, then you're much more dispersed and you're much safer in terms of virus transmission. You're also maybe not as well connected to other people socially as you might hope to be. So maybe what you need is some optimum between those two. And that's the idea of the perimeter block, that you still might have stairwells or elevators that bring people into closer proximity, but it's only small groups of people. It's not the entire building that's sharing one lobby, one entrance or whatever. And so I think we need to understand that these network spaces in buildings that are not tree-like, but are more interconnected, more web-like, are also important when it comes to safety and virus transmission and things like that. So I think these are challenges that are still very relevant, that we can continue to work on. We can continue to use the pattern language methodology. I think there are many examples of things that we could be doing with patterns. I find it a really exciting domain and a kind of open-ended domain in a really interesting kind of way. So that's a good note to close on. How much time do we have? Well, a little more than 10 minutes to go. Dominic, have you been able to follow us and hear everything?
Thank you for this interesting lecture. From my perspective, a pattern can be treated as an alphabet. Through patterns, we can write down the words in general. We can apply the language of patterns to every
It's a generative system like languages, or like an alphabet is. You're right. Yeah. Were you able to see all the images okay?
Could you repeat?
Were you able to see the slides okay?
Yeah.
Good. Okay. I just wanted to make sure the technology was working. So I'm showing this on an Apple, and the Apple system includes patterns, by the way, the language for the iPhone, the Cocoa language, and a number of people who were key to the original pattern languages of programming or design patterns went to work for Apple. Steve Jobs was said to be a fan, and you can see that in the software world, certainly it's the logic is very appealing for obvious reasons. We're trying to network the world. Literally, we're trying to build web networks, including obviously the internet itself, which is a more resilient system. The internet was designed to withstand attacks, actually, by the military. So anyway, Dominic, sorry, I cut you off, and I wanted to hear what other points you might have seen and reflected, thought about.
Yeah, software development is indeed one of the most popular area of pattern languages nowadays. But we can apply the language of patterns to every area of our human life. And during my earlier studies, I started to learn more about pattern languages, but in the context of script languages, programming languages, and modeling in mathematics and computer science.
Right.
For instance, C++, Python, etc. And I had to write down as well as read some patterns written in a specific theoretical or programming language. And thanks to your classes, I'm expanding my knowledge of pattern language and its applications. This has given me the motivation to look for a pattern language also in my field and to look for its application in management as well. In fact, pattern language is very rarely mentioned in the context of management sciences, but it doesn't mean that it's not present and applicable there. A wider application of pattern language in management would certainly, in my opinion, make it possible to write some problems in computer language, but on the other hand, it would also make it easier to present and to more easily solve some complex problems in general. In addition, I believe that pattern language enables convenient as well as quick exchange of information between people who know this language. And this also applies to specialists collaborating in interdisciplinary projects. What could I also say? In my opinion, a very significant application of pattern language is, for instance, cryptography. Already in ancient times, various algorithms were used to encrypt information, to give new patterns to the letters of the alphabet, so that some enemies would not learn the secrets others wanted to convey. And cryptography is extremely valuable nowadays and is finding more and more applications in every area of life due to the increasing digitalization. And for me, for some, the pattern language enables some secret encryption of sensitive information, but for others, pattern language is something they necessarily want to know and decipher in order to defeat the enemy. And it can be therefore be admitted that pattern language rules the world in a certain way, because without it, it would not be possible to write some things down reliably and efficiently. Yeah, so it's extremely important.
I would encourage both of you guys to just Google around like I just did. I just typed in, as you see, cryptography, quote, pattern language, and I got, well, 395,000 results. I think probably a lot of noise in that number, but as you can see, it's a ubiquitous field. And by the way, in management too, Dominic, I mentioned that agile management is agile methodology is directly an outcome of pattern languages and of the, you know, the work with Ward and others who signed the Agile Manifesto some years ago. So I type management and then pattern language, I get 728,000 results. A pattern language for innovation management, a pattern language for learning management, pattern language, project management pattern language, towards a pattern language for leading organizations, et cetera, et cetera, et cetera. You can almost, you can find so many examples. Did I show you guys, by the way, this, the essay by Ramray Bhatt, there was, I can send you this link or you can Google it. This is one that he wrote with his colleague Stuart Newman, where they essentially used a pattern language model to try to explain the evolution of multicellular life in biology. Quite an interesting paper, to say the least. And then Bhatt also wrote, let's see if I can find it here. I can't lay my hands on it, but another one where he looked at the analogy in environments and the idea that what's going on in some environments is analogous to cancer. Let's see if I can find that paper on that one. Hold on a second. I'm going to go to Scholar. There we go. Understanding complexity through pattern languages. And I can send you guys links to these. They're really interesting papers, to say the least. If it will load here. There we go. In biological and man-made architecture. So what he does, he's a biologist, was at Lawrence Berkeley Labs. I think he's moved to another laboratory now, but at any rate, doing really interesting work, I think. So he takes the example of pattern languages in biology, the work that he and Newman did and others, looking at it as a kind of natural explanation of what's going on in structure as structures evolve and as they do this symmetry breaking and this reformation. It's a pattern language like process, actually. The pattern language in a way is recapitulating that. And in fact, I once asked Chris Alexander, was there one big takeaway that you concluded when you coming out of your work with pattern languages? He said, yeah, actually there was. He said, I thought I was inventing something, but I now realize I was discovering something. He was discovering something about the way the world actually works, the way structures actually work, the way they transform and interconnect and create patterns, literally create structures and break the structures and create new ones and so on. And so this is a really interesting paper, I think, and I'll send you the link to it. Lots of fascinating stuff going on in this and in other fields. Anna, do you want to make any other comments? I'm going to move the computer so we can hear you a little better.
I have my phone. I'm sure that nobody can hear us because we're both on.
Oh,
Okay.
sure.
Yeah, so yeah, I have many notes. Actually, I can tell that the more I think about it and the more I talk about it with others, because I tend to confront my knowledge with other disciplines like medicine, or also computer science, and so on, so on. So it seems that, in fact, there is, when you're able to see the pattern, it also starts is a good start for us, some sort of standardization, right? So same with what in the job that my husband holds. He is a flight instructor, and he also has this. I was shocked because there is actually a pattern of student behavior, what you should be aware of, and who is apparently going to be a good pilot and who maybe rather should stay on the ground. Well, then I told you yesterday that I'm planning to design, to have this side project that I hope to develop, to involve into the design people that are not connected to architecture in any way. And the first one would be a film director versus, he also does photography and so on, from our film school. And yesterday I was able to talk with my colleague who is working close to him. And I was shocked that he could express more or less everything that we are talking about, but he told that he expects that I will make a room for evolution over time. He said that proposed building should be interesting from any distance, from any, like that when you interact with it closely, it should have some interesting structure, and like from far, structure. Yeah, and from the far, he expects some kind of vivid form that will fit. Then he also said that he wants to see the different spaces where you can decide if you want to interact with others and if you don't want to interact, right? Crucial, So this is something that blew my mind, because often as architects we do not have this purpose, and we don't have this things that we write down or think about at the beginning, and it somehow just we don't follow any vision. We think about the form, the colors, the factors, everything that will somehow make a building, but not a space, I think.
I think you're right. We're solving the wrong kind of problem, I think.
Yes.
In that sense.
I was shocked that he can name it so easily and quickly, just because he's looking through the lens and he knows what he wants, what he expects. He wants an environment that is beautiful to live in, because he has this sensitivity for colors, for structures, for detail. He is doing cinematography, cinematography. Sorry, hard to pronounce for Polish people, I guess. And he just developed it without any connection to architecture. I also asked, when he chose the plan for the film, what he's looking for, and he said that there's a lot, but though actually there also is the same pattern: to look good from the distance, good look in a close frame, right? And again, like create a shadow, a light, a movement, some sort of, right? So it's shocking that I just, as an architect, I don't think about the space that clearly. This was something painful, but
well, I think we have a lot to learn from other professions and other fields, as I think that's the theme that I hope you have seen run through the course. My son-in-law is a pilot, by the way, and he let me do some flying, and it's a pattern-like process because you know what the rules are, right? You know that, okay, I've got to pull the yoke at the right time, and I've got to do, but you're always responding in real time to everything that's happening. You're sort of surfing the atmosphere in a way. It's a wonderful feeling, but it's also you have these models of, okay, in this situation, this is the procedure. You have these procedures and these checklists and these things that you go through that are very pattern-like, actually, I think. And yeah, and speaking of filmmaking, I was fortunate to be able to study that a little bit myself and be a very modest filmmaker, and I see a lot of relationship to that. Also in music, I would study music, and the qualities of space and the qualities of all the things that we're talking about structurally, the fractal properties, the boundaries, the strong centers, they occur in music, and they occur in film, and they occur in every domain you can think about. And if we don't engage ourselves as architects, and not only engage ourselves as architects to create those kinds of forms, but also to create the affordances. This word affordance that I mentioned, that's a category of the patterns, where people themselves can interact with the world that we've created, can open and close windows and move things around and change their lives the way they need to. You give them power, you give them malleability, and I think that's really something that we don't think about enough in architecture. I'm just about out of power here, I see, and I think we're probably about out of time too, but it looks like everything has worked, I hope, and we'll pick it up again tomorrow at this time. So Dominic, we'll see you tomorrow.
Thank you very much for
today. Link again.
Afternoon.
Great.